In this video, I'm going to be describing different ways that we can talk about measurements of angles. So you should be familiar with degrees as a measurement for an angle. But we also have another way of describing that measurement. They're called radians. And in much the same way that we can describe distances using different units, it's the same sort of concept. We can describe measurements of angles in more than one unit. So just like a yard represents 3 feet, we're using 2 different units to describe the same length. We can do the same thing with degrees and radians. So even though we're talking about the same measurement, we can describe them in 2 different units. And so we'll talk about what radians are and the conversion. How do we get from degrees to radians, or how do we go the other way from radians to degrees? Okay. So if we have a circle, whoops. Let's try again here. Alright. Imagine that's right in the middle there. If our radius, so from the center of our circle to the outside, if that distance, that radius length, measures 1 unit, then we can start to describe angles in a different way here. So if I want to describe the distance around this circle, I would be talking about the circumference. That's what the distance around a circle is described as. And to find the circumference of any circle, you can use this formula, 2 pi r, or I like to write it 2r pi, because then it just shows you that you're really just doubling the radius and multiplying by pi. So if we double our radius, 2 times 1 is still 2, and we leave pi as pi. So we can find that the circumference around a circle, if the radius is 1 unit, is just 2 times pi. Or in other words, the distance around a circle is 360 degrees. So we can also define 360 degrees as equal to 2 pi. And this right here is the beginning of radians, because if I can describe 360 degrees in a different way, we'll call them radians, then I can describe it as 2 times pi being the exact same distance. So radians are often in terms of pi, but they don't have to have pi. And so I'll try and emphasize that as much as possible. A lot of your distances around a circle will have pi as part of the measurement, but radians do not have to be in terms of pi. Okay? So the distance around a circle is equal to 2 pi. Well, half of that, 180 degrees, would be half a circle. And if I divide this side by 2, I would get 1 pi. So 180 degrees is also just pi radians. So 360 degrees is 2 pi radians, and half of the distance around a circle is just pi radians. And I know it seems kind of silly, because, I mean, ideally we would want the distance around a circle to be just 1 pi, because a pi would be a pi, and that would make a lot more sense than 2 pi, but it's just not the way it is. So 2 pi is the total distance around the circle, and 1 pi is a semicircle, or halfway around the circle. And we can continue to do math with these two in order to come up with some other general important pieces of our circle. So if I divide this in half again, then I can figure out what 90 degrees as radians is. 90 degrees would be half of this. So if I do pi divided by 2, well, then that would be equivalent to 90 degrees, except pi over 2 would describe it as radians. And we can continue to do it again. If I divide this by 2 again, I can define 45 degrees. And 45 degrees would be this divided by 2 again. Remember that dividing by 2 is the same as multiplying by 1/2. So I still get pi on top, but on the bottom I'm multiplying 2 times 2, so I get 4. So Either 1/4 pi or pi over 4 is 45 degrees. If I go back to 90 degrees, I can cut this a little bit differently. What if I divided it by 3 so I could figure out what 30 degrees is? So if I divide 90 by 3, I get 30 degrees. If I divide this side by 3, I'm multiplying by 1/3, so pi stays on top. But instead, I do 2 times 3 on the bottom and get 6. So 1/6 pi, or pi over 6, is equivalent to 30 degrees. And if we double that, we can easily see what 60 degrees is. So if I just multiply by 2, that would be 2 pi over 6, and that would reduce to pi over 3. So 360 degrees, 180 degrees, 90 degrees, 60, 45, and 30 degrees all have these pretty standard radian amounts. And it's really nice to have those memorized. Keep them in your back pocket because they will be used quite a bit. Now, to get the in-betweens, like how many radians is 100 degrees? That would be somewhere in between these two, right? I will give you a formula that will make that a lot easier to solve. But for now, think about these general measurements, 360, 180, 90, 60, 45, and 30, and then try and study those radian amounts that are equal, and I promise you it'll make your life a little bit easier. Alright, let's move on a little bit. Let's figure out those in-between amounts, and how we can figure out just what 100 degrees is radians. To convert degrees to radians, anytime you want, all you need to do is do a simple multiplication. You're going to multiply whatever your degrees are and whatever your angle is. Let's call it theta for now. You're going to multiply that angle measurement in degrees by pi divided by or over 180. You can put degrees there. I'll show you why our degrees will cancel and we'll be left with radians. So if you do that simple multiplication there, you can convert from degrees to radians. For example, if I have 110 degrees and I want to convert it to radians, I simply set it up to multiply. Multiply by 180 on the bottom, pi on the top. And we multiply fractions straight across. So one trick you can do is to cross reduce before you multiply, or you can save reducing until the end. It doesn't matter. I'm going to save it in the end in this example, just so I can show you that you multiply straight across. And then reduce. Well, this is easily reducible. If we just divide by 10, we can take those zeros off, and we're left with 11/18 pi, or 11 pi over 18. It doesn't matter. And that would be in terms of radians. Some books will ask you to leave it in this reduced ratio form. Other times the book or your teacher may ask you to take it all the way to a decimal form. So in order to do that, you would do 11 divided by 18 and either multiply by the button pi on your calculator or multiply by 3.14, and then you may have to round it to a couple decimal places. Just make sure you're reading the instructions when you're solving these problems. So that's degrees to radians. If I want to go radians to degrees, just the other way, you might have already figured out what you think we might be doing. We're just going to flip that fraction over and multiply by the reciprocal of what we just did. So if I want degrees to radians, I'm going to take my radian measurement there, and I'm going to multiply by 180 over pi this time. So really the hardest thing about this is knowing which of these two ratios to multiply by. So it just takes a little bit of memorizing to do. I often think that if I want to convert 2 radians, then I want, usually in terms of pi, so I want my pi on top, and I want my degrees to cancel on top and bottom. So 180 would be on the bottom, pi would be on top. And if I want degrees, well, I know I want degrees, so my degrees would be on top, right? 180 degrees would be on top, and then hopefully I can get my pi's or my radians to cancel being on top and bottom there. So the pi would be on the bottom in that case. There are little rhymes that you can learn, little mnemonic devices that you can use to memorize, but I usually leave that up to my students to be creative with. So let's go radians to degrees. If I want to find out how many degrees pi over 4 radians is, then I multiply by 180 over pi. And you can see here that my pi is going to cross cancel or cross reduce, become 1. So I'm left with 180 over 4. Now we're in terms of degrees, that's what we wanted. And now you just got to reduce this fraction or do the division of the ratio. So 180 divided by 4 is 45, and we want degrees. So pi over 4 radians is 45 degrees. Now if you had been paying attention earlier on in the video, you probably would have got that just because you already knew those basic fractions of our circle there. But even if you don't remember, here's how you can just figure it out the long way. Alright, so degrees to radians, multiply by pi over 180. Radians to degrees, you want to multiply by 180 over pi. And you should be able to go back and forth converting degrees to radians all day long if you wanted. So good luck converting degrees to radians and radians to degrees.